I will explain question 1. Explain the meaning of differentiation. What is differentiation? Differentiation is the process of finding the derivative of function with respect to an independent variable. It measures how a function changes as the variable change and can use to determine the rate of change and the slope of a curve at a given point.
Let y equal to fx be a function of x, then the rate of change of y with respect to x is given by dy over dx. In a simple terms, it tells us how fast the value of y change when x change. This rate of change is represented by dy over dx, which is called the derivative of y with respect to x. The second one, if fx with respect to x is the function of f prime x and is defined as f prime x equal to lim h to approach to 0 fx plus h minus fx over h. In this formula, h represents a very small change in x. The expression of fx plus h minus fx calculates the change in the function value, while dividing by h gives the average rate of change. As h approach 0, the average rate of change becomes the instantaneous rate of change. This is known as the derivative or f prime x.
So, what are the techniques of differentiation? Differentiation techniques are the methods and rules used to find the derivative of a function. These techniques is simplify the process of finding derivatives, especially for complex functions. So some of the techniques of differentiation is we have power rule is used when differentiating terms with exponent. So basically we have to bring power to the front and power minus 1. Next we have product rule used when two functions are multiple together. And the last one for this slide is quotient rule used when one function is divided by another. Other than that, we also have chain rule is used for composite function, which is a function inside another function. Then we have implicit differentiation is used when I is not isolate on one side of the equation. Not only that, we also have exponential and logarithm differentiation. And the last one is trigonometric differentiation, which is differentiating trigonometric functions, which is since, cos, tangent, cosecant, cotangent, and secant. That's all for the techniques of differentiation.
For the question 2b, find dy over dx for the following function and simplify. Since the question is using fraction, then I'll use quotient rule as a formula. Dy over dx equal to vu prime minus uv prime over v square is a formula of quotient rule. The first step, I will identify the value of u and v. U is equal to 7x plus 2, v is equal to sin x. Then the next step, I will differentiate both functions. U prime equal to 7, v prime equal to cos x. For the u prime, how do I get it? We need to add a little bit calculation, which is 7 bracket 1x 1 minus 1 multiple 1 close bracket plus 0. 0 because it's a constant because 2 is a constant, so it will be 0. Then for the v prime, we need to use formula. So the next step, I will substitute all the values of the quotient rule. I will substitute all the values into the quotient rule formula, which is dy over dx equal to sin x bracket 7 minus bracket 7x plus 2 bracket cos x over sin x square. Then I will simplify the expression by multiplying. So 7 multiply by sin x minus 7x plus 2 multiplied by cos x over sin x squared. Then we got the final answer, which is 7 sin x equal to 7x plus 2 cos x over sin square x.
I will be explaining how to answer question 2i, which is find dy over dx for the function y equal exponent to the power of cos 2x sine 2x. Firstly, we have to identify the u and v of the function. The u usually sits at the front, while the v usually sits at the back. So the u for this function is exponent to the power of cos 2x, while the v is sine 2x. Then differentiate both u and v to get u prime and v prime, which we will use in the next step. For the u prime, we have to differentiate exponent to the power of cos 2x. To differentiate exponents, first, we write the function which is exponent to the power of cos 2x. Then, differentiate the power, which is cos 2x, to be multiplied with the function. According to the differentiation formula, cos x will result to negative sine x. So, cos 2x after differentiating will be negative sine 2x. After that, identify the subject of the power. The subject is 2x, so we differentiate the 2x, which we will get 2. The 2 will be multiplied along with exponent to the power of cos 2x and negative sine 2x. So, the u prime is exponent to the power of cos 2x in bracket negative 2 sine 2x. Next, we're going to differentiate the v. To differentiate sine 2x, we'll have to know that differentiating sine x will be going to be cos x. Hence, in this case, it will be cos 2x. Then, we have to differentiate the 2x, which we will get 2. After simplifying, cos 2x times 2 we'll get 2 cos 2x as the answer for v prime. For this function, we have to use product rule because in this function, there are two separate functions. As we all know, the formula for product rule is dy over dx equal uv prime plus vu prime. We'll substitute the values that we had differentiated earlier into the formula. So we'll start with u, which is exponent to the power of cos 2x, times v prime, which is 2 cos 2x, plus v, which is sine 2x, times u prime, which is exponent to the power of cos 2x, times negative 2 sine 2x. Then we can factorize, so it will be 2 exponent to the power of cos 2x in bracket cos x cos 2x plus sine 2x bracket negative sine 2x. We can multiply the sine 2x and negative sine 2x together, so it will be sine square negative sine square 2x. So the final answer for this question is dy over dx equal to exponent to the power of cos 2x bracket cos 2x negative sine square 2x. That's it for this question. Thank you.
So the question is, for my part, is 5y squared plus sin y equals to x squared. So we have to find dy per dx for this equation using implicit differentiation. So what should we do first is separating the terms, our first term, our second term, and our third term. And then our first term is 5y squared d per dx. Here we can apply power rule. What is power rule? Let me remind you that power rule is d per dx, x having the power of n will be nx having the power of n minus 1. So what will happen here is power of 2 will bring it to the front, and then we'll minus it with 1. So it will be 2 times 5y power of 2 minus 1 d per dx. And then we just have to simplify. 2 times 5 is 10. Y having the power of 2 minus 1 is 1. So we just have to copy back the y and copy d per dx. And because we are differentiating a y term, so it will be 10y dy per dx. This is our first differentiated term. So our second differentiated term is sin y d per dx. In here, the sin y, we can replace it with cos y, because the formula is d per dx sin y equals to cos y. Actually, is an x. Wait, let me sin x equals to cos x. So in here, we will just replace the sin y with cos y. So cos y times y d per dx. We can apply the power rule again on y, and it will be cos y times, open bracket, y having the power of 1, so we'll bring 1 to the front, y having the power of 1 minus 1 d per dx. And this will bring us cos y d per dx. And because we are differentiating a y term, it will be cos y dy per dx. This is our second term. Our third term is x squared. Very simple. We have to apply the power rule again. Bring the 2 to the front, and then minus it with 1. We will have 2x having the power of 2 minus 1. So then we'll just have to 2x here. And I forgot to mention, we do not have to copy back d per dx because we are differentiating an x term. So the last answer will be 2x. And then after differentiating all of them, we have to rearrange them and bring them back into the equation to find dy per dx. So how do we do it? 1 plus 2, first term plus second term equals to third term. Why do I use plus? Because in the question it uses plus, so we have to use plus 2. So the first term that we have differentiate, 10y dy per dx, plus our second term, which is cos y dy per dx, equals to 2x. And then we simply have to factorize by bringing the only the dy per dx to the front, and then it will be dy per dx 10y plus cos y equals to 2x. And because we have to find dy and we are searching for dy dx, we just have to bring 10y plus cos y to the back, and it will be dy per dx equals to 2x per 10y plus cos y. And that is our last answer. That's all for me. Thank you.
For question 4b, use linear approximation to estimate the value of the following problems, correct to 4 decimal places. So the expression of question B is 16.02 power 3 over 2 plus 2 times square root of 16.02. For the step 1, we have to determine x and x naught. For this expression, x is 16.02, and since 16.02 near with 16, so the value of x naught is 16. Next, we have to change the equation into functions. So it will become fx equal to x squared 3 over 2 plus 2 times square root of x. For step 2, we have to find delta x using the formula x minus x naught. So 16.02 minus 16 is equal to 0.02. So the value of delta x is 0.02. For the step 3, now we have to use the linear approximation formula, which is f of x naught plus delta x equal to f x naught plus f prime x naught multiple with delta x. We have to enter the value of x into the formula. For the step 4, we have to differentiate the function that we already changed in the step 1, and we have to differentiate it one by one. To differentiate the function, we have to bring power to the front, and power we have to minus 1. So here we have, after differentiate, we got 3 over 2 times x power of 1 over 2 plus 2 times 1 over 2 times x power of 1 over 2 minus 1. Then we have to solve the differentiate, and we got 3 over 2 times square root of x plus 1 over square root of x. And then step 5, we have to solve the equation one by one. So for f16, we can take it from the question and from the function that already changed. So we have to substitute 16 to the x. And for f prime 16, we have to take the equation from the function that we already differentiate. And we have to substitute 16 to the x and multiple with delta x 0.02. Then for f16, we can solve it, and we have 72. And for f naught 6, for f prime 16, we have to multiple with 0.02, and we got 0.125. And for the answer is we have 72.125. For the last step, we have to make the answer into 4 decimal places. So the final answer is 72.1250.
To sum up, the techniques of differentiation incorporate such as power rule, product rule, quotient rule, chain rule, and implicit make the process of solving differentiation problems easier and more convenient. This is because finding derivatives of functions by using the definition of the derivative for certain functions can sometimes be too long, complicated, and undeniably a challenging process, especially for students. Hence, these techniques were developed to allow us to bypass that complicated process. Thank you.